You've been there, right? You're in a meeting and a leader is demanding a bulletproof plan. They want a guarantee, a sure thing. But all the experts in the room can give are probabilities and, well, educated guesses. It's such a classic and frustrating situation. So let's unpack why that happens and how we can bridge that communication gap using a really powerful but often misunderstood concept, effect size. Our story starts right here, smack in the middle of a tense moment. You can just feel the impatience, can't you? A leader is facing this huge, smelly problem, and he wants it gone, like yesterday. And he's looking at his team for a simple, fast fix. So here's the scene. We've got our leader staring down a massive obstacle. He's got his team, they're ready to go, but they just can't seem to give him that simple, guaranteed plan he's asking for. He wants to know exactly how long is this going to take. But as helpers, they come back with, well, that kind of depends on the tools we use. Are we working with spoons here, or spades, or maybe even tractors? And that's the real problem, isn't it? The leader is demanding certainty, but the team knows the outcome completely depends on the tool for the job, and every single choice has its own level of uncertainty. So the helpers, they try to reassure him. They say something like, look, as long as our test shows a significant difference, we'll know the tool is working. But right there, that word significant is probably one of the most misunderstood words in all of statistics. And you know what? It almost never means what people think it means. Okay, this is absolutely critical to understand. When a scientist says a result is statistically significant, all they're really saying is that what they saw probably wasn't just a random fluke. The tool, it did something, but it doesn't tell you if that tool was a tiny little spoon or a giant earth-moving tractor. To know that, you need to understand practical significance, and that, my friends, is effect size. Our leader, he's getting frustrated with all the jargon, so he just cuts right to the chase. He wants to know about the real-world impact. And boom, there it is. He asks the million-dollar question, and he wants it in plain English. He wants to understand the magnitude of the solution. So what is he actually asking for when he says that? Effect size is, well, it's pretty much exactly what it sounds like. It's a standard way to measure just how big an effect is. It takes you beyond a simple, yes, it worked, or no, it didn't, and tells you how much it worked. It's the number that tells you if what you found is just a tiny tremor or a massive earthquake. So let's bring it right back to our story. Effect size is the real, practical difference between the tools. It's the metric that finally answers that question. Are we trying to clear this huge pile with a spoon, a spade, or a tractor? Each one of those tools has a very different effect size. Now, to make this super practical, we often use a measure called Cohen's d. It's great because it gives us these simple benchmarks to understand the impact. So think of it this way. An effect size around 0.2, that's small, that's our spoon. An effect size of 0.5 is medium, that's our spade. And anything 0.8 or higher, that's a large, really powerful effect. That's our tractor. It gives everyone a common language to talk about impact. Okay, so the leader has another worry. He's heard from his AI friend that their current setup might be a little weak or underpowered. And this brings up another absolutely critical piece you need for any so-called bulletproof plan: statistical power. He's asking a really smart question here. Is being weak or underpowered the same as just being wrong? Well, not exactly, but it's just as dangerous. Because an underpowered plan is basically a plan that's been set up to fail from the very beginning. So what is statistical power? Simply put, it's the probability that your test is sensitive enough to actually find a real effect if one is there. You can think of it like the quality of your metal detector. If there's buried treasure, what's the chance your detector will actually start beeping? That's power. Let's look at the risks here. A type 1 error, that's a false alarm. You think your little spoon is a tractor when it's not. But a type 2 error, you could argue that's even worse. That's when you have a real working tractor, but your test is so weak, so underpowered, that it completely misses it. You conclude the solution doesn't work, when it actually does. Statistical power is your #1 defense against making that massive mistake. So how much power do you actually need? Well, the standard in most fields, the target, is 80%. What this means is you're giving yourself an 80% chance of finding a real effect, assuming it's out there to be found. If you go much lower than that, you're pretty much flying blind, wasting time and money on a plan that might not even be able to prove its own success. To put it as simply as possible, power is what makes sure your plan is actually capable of telling the difference between a tool that works and one that doesn't.
If your plan is underpowered, even if you have a tractor sitting right in front of you, you won't have the evidence to prove it. Your results just become meaningless. And this brings us to the final and I think most important question. It's really the heart of our leaders' frustration. How in the world can you design a powerful plan if you don't even know if you're dealing with a spoon, a spade, or a tractor before you even start? And there it is, the ultimate catch-22 of planning and research. To figure out how many resources or people you need, your sample size, you have to guess the effect size. But you can't really know the true effect size until after you've already run the whole experiment. So what do? The good news is you don't have to guess blindly. You make a smart, educated estimate. You could run a small pilot study to get some early data. You can dig into past research on similar projects. As a last resort, you can use those Cohen's benchmarks we talked about. Or, and this might be the most strategic move of all, you can decide ahead of time on the smallest effect that would still be a real win for you, and then you plan for that. You see, we have to kind of redefine what a bulletproof plan even is. It's not about having a crystal ball that predicts the future with 100% certainty. It's about understanding concepts like effect size and power, so you can design a plan that is strong, that has enough resources, and that has a really high chance of detecting a meaningful result if one actually exists. It's about managing uncertainty intelligently, not pretending you can eliminate it. So that brings us to the final thought I want to leave you with. The next time you're facing a giant pile of obstacles on a project, just ask yourself this. Is my plan powerful enough to actually tell me if my solution is a tractor? Or am I just crossing my fingers and hoping for the best with a spoon? Because having the power to know the difference, that's everything.